Okay, so I'm Deepanker. We run a company by the name of Ajanta Bottle Private Limited, which deals in glass bottles or food, pharma, cosmetics, spices, pickles, jams, any product that you name. We have bottles for solution और उसमें हम बहुत सारे brands के साथ काम करते हैं. So 5 sections to the presentations primarily: understanding of glass, making the right choice, industry-wide usage of glass bottles, solutions to common problems, and then the quiz, right? Can you very short thing, this is a type of glass. किसी ने देखा है कुछ ऐसा? Volcano site visit करिए कभी किसी ने? All right, so when volcanoes happen, so sand जो है बहुत pressurized environment पे गर्म होती है, and when it cools down, it forms a kind of glass. So this is a nature's way of making glass. आप समझ रहे? So this is known as obsidian. You know, एक we always say कि glass तो कभी ना biodegrade नहीं होता. वो degrade क्यों नहीं होता? Because वो natural form में ही है. Sand can never degrade it. Sand is the final form of degradation. So similarly, any glass that you crush will finally become sand. So the idea is to tell you, glass is the only packaging material which is 100% natural. And you don't have to do any further process to it to make it biodegradable or to recycle it or to do practically anything. So when excavations used to happen, जब when there are old sites, excavations होती है, historians निकालते हैं, they used to get things like these, knife, jewelries, and some daggers. So these were made of glass, which was formed by the lava formations in the volcano. The idea of telling you this is to communicate that glass is a totally natural product. And now when we make modern glass, can we open this box and distribute the bottles? Now we replicate the same process in the manufacturing environment to make glass bottles. जो rocks बनते थे, molten glass होता था, molten glass used to become rocks. Now if you put that molten glass into molds and use air to blow them, it gets into bottles. This is the evolution of glass. We will skip this. So earlier they were glass. So this was how it used to happen historically. So there used to be a molten glass, and manually it used to be blown with the mouth with a long pipe. So these are the bottles which are made on machine. And this is how modern day bottles are made. Just have one bottle each. So we'll use these bottles to see some parts of the bottles and various things. Time to observe. And these bottles you can take home. So you can see it very easily. You can observe and do everything. इसके बारे में भी हम पढ़ेंगे भी. So now let's focus on the what I want to discuss with you. Okay. So is everybody clear that how glass is natural? कि natural environment पे बनता है? बहुत short time. Otherwise, I really make it very interactive. We have very short time. I don't want to hold you. I want you to enjoy Delhi. So इसलिए let's just keep it short. Okay. So you understand glass is a natural form. If glass is molted, अगर sand को आप melt कर देंगे, just keep it like that, it becomes a obsidian. And now when we melt the glass and put it into molds, it becomes a bottle. Right? So it is absolutely natural. If you put this glass into soil today, even after thousands of years, you will find the bottle like this. And it will not impact any of the surroundings because it is like sand. Right? And this is the evolution of glass. Earlier it was blown manually. Now it is done in fully automated plants. All right. So this is a brief about what all goes into when you make glass, right? So one is former. Former is sand and cullet. Cullet is basically broken glass. When you use the glass, you can crush it and put it back in the furnace, which is like a huge tank where sand is melted, and it comes at the same quality. The good thing about glass is whenever you crush it, put it in the furnace, and then you remake into glass, it comes to same quality. Whereas in all other packaging material, with every recycling, the quality keeps on degrading, right? So in actuality, that is not recycling, that is downcycling. The real recycling happens in glass. If I crush this bottle and make this bottle again using this glass, it will bring out the same quality. So this is the beauty of glass, and you can do it thousands of times without impacting any quality. And then there are some other minor which are stabilizers, fining agents, little bit of colorants. So that is a very small part of the total ingredients. And the collect percentage can go as high as 60-70% also. There is a problem of waste collection. That is why there is a lot of opportunity for e-waste companies, that they can collect a lot of glass and supply to glass companies, because there is a lot of shortage of broken glass and we are not able to get the broken glass. That is why we have to use more sand. The more broken glass we use, it reduces the melting temperature also, because melting glass is easier than melting sand. Glass can melt at about 1000-1200 degrees, but sand melts about 1500 degrees. So you need less fuel if you melt the glass. So that is why companies want to buy more and more broken glass to make more glass bottles. Right? These are two parts of the manufacturing. One is the batch house. So in batch house you have raw material, silica, soda lime. Raw material is silica and soda lime. Then is preparation, which is grinding, weighing and mixing of the various parameters. And then it is hot end. In hot end, the first process is forming, wherein you form the bottle. The second process is annealing. This is the most important process of the bottle, which is annealing, which actually gives the strength. So you imagine if there are potteries, like how matka, you understand matkas and the potteries. So when you bake them and then you slowly cool them down, because if it has a 600 degrees and you suddenly bring it to room temperature, there will be a lot of stresses in the bottle and it will eventually break. So this annealing process helps to gradually reduce the temperature of the bottle. So when the bottle is formed, it was 700 degrees, and after the annealing process, it comes out to be at 660 degrees, wherein it can be easily handled. So this is the most important part of the manufacturing to get it to the strength. Then it is inspection and packaging. Right? So this is the mixture of sand, broken glass and some other natural substances, and this is pushing the sand in the furnace. Then that glass comes out and these are gobs being cut in the weight of the bottle. So what is happening here is that glass comes in the first mold. It makes kind of a parison. Anybody heard of preforms in plastic bottles? So it's kind of a preform or a parison. Then it is moved to another mold wherein hot air is blown and it makes the shape of the bottle. You see it is being transferred and this is the final bottle being made. So at this time it's about 800 degrees or so. When it melts, it's about 1500 degrees in the furnace. Then when it comes down, it cools down a little bit. And right now, even if you pick a pin in the bottle, it will blast, because it's under immense stress in the glass at this point of time. And now it is going to annealing chamber, which I just discussed. So the bottle it comes from there, it has cooled down, and then it is going to packaging. This is an inspection machine where each and every neck is being checked. This is also inspection machine to check the neck of the glass bottle, so that when you pack, carbonation is not leaked. If you're packing milk, it does not curdle, and there's proper sealing. So these are all camera based inspections. This is the inspection for the inner bore. So if there's any rejection here, when the bottle goes further, it will go to a back conveyor and it will go back to the furnace. Any bottle which is rejected. Now this is the packaging. So it is packaged in pallets or in boxes depending on the client's requirement. Now when we see this, you will have more clarity. So this was the glass was being dropped from the top of the furnace. Alright. then there is this parison that goes in and it forms this kind of a shape, right? So this bright yellow that you see is the glass, and then this is transferred to another mold, and then hot air is applied. These red arrows are hot air, and this hot air gives the bottle the shape, right? And then there are tongs. The bottle is picked up and then moved to the conveyor. Find out somewhere here you may find a mark where the bottle was picked up from, or you see this ring. You see the ring which is going across. So this is the ring which is used to hold the bottle and keep it on the furnace, right? This is known as transfer bead. What is it known as? Yeah, so very simple. Transfer करने के लिए bead है, so transfer bead. So this brings us to an important thing, that what happens when we are talking to our suppliers or customers or production team, we are not able to discuss which part of the bottle there is a problem or to be observed, right? So let's start from the top. This section, which is the neck section, is known as the finish, because bottle is finishing over there. It starts from the bottom and it finishes on the top. So these four, they fit in exactly in the, when you do it anti-clockwise, put it anti-clockwise, can you hear a sound? Right? And then you make it a clockwise move, right? So these are lugs, right? Then is transfer bead. Now can you see the line, a vertical line, right at 180 degrees of each other? I want you to tell me that how many mold joints do you see in the bottles? So this is 1, 2. There are more mold joints. So you can see when the mold closes and opens like this, these are the 2 mold marks. Then there is a neck. Just below the bead you will see one line, because that is another section of the mold. And then you will see one line over here, right, on the body on the outer side, because this is another part. So although mold has lot of parts, but broadly these are the 4, 1 bottom plate, neck and 2 side. 4 primarily they come together to form a bottle, right? A lot of time customers ask us that we don't want these lines. Then imagine there is a mold which doesn't open, which just remains closed, and we have put glass and we have blown. So we will have to supply the bottle with the mold to the customer. So the customer says, I don't want the mold to open, right? So you understand that problem? Okay. So you got this mold seam. This is known as mold seam. Then you see this thing, bottom ring, bottom plate parting line, and this portion known as heel, right? So it's just like a human body. This is neck, this is shoulder, this is body, this is heel. So you can compare it with a human body, right? This is the sidewall, which is very basic, which is used for labeling. Any questions? Anybody want to ask any logic? I think very good question what she has asked. Can anybody tell why do you have these are known as knurlings. Knurling, Knurling. Can anybody share why are these knurlings made? To reduce pressure? To? Not to slip. Not to slip where? Which surface? So during transportation the bottle goes like this. It is not moving, right? The reason is, right, it is made so it doesn't slip, but where? So imagine when you have a conveyor, and if it does not have a grip, the conveyor will keep moving and bottle will be stationary. Getting it? Because there will be no friction to move the bottle further. So that is why to move it further we need some friction and some kind of holding at manufacturing process as well as customer line process. So these knurlings are made for that purpose, right? And second purpose is to have even distribution of the temperature, because if the entire base is touching the base, the temperature can transfer more. With this, the temperature transfer is also less in the conveyor during the manufacturing. So what do you think should be a parameter to see how strong a bottle is? So I think weight is something that has been because we buy a lot of things by weight, and we feel with whatever is weighing heavy is good in quality, but it is not right in case of glass. In case of glass, what is more important is the uniformity of the glass. If you have more glass here and less glass over here, and the pressure is applied, where will it break from? Right? Have you heard the weakest link breaks? Right? So if it is uniform, and even if it is thin on all the sides, it will not break as much. So I'd like to show you some innovations that we have done. So like 400 gram bottle was earlier being made in 225 grams. Now it is made in 155 grams. So that is an overall reduction of 31% in the weight. Right? And the new bottle is more stronger than the previous bottle. Right? So a lot of times there might be suppliers who are not able to make bottles in very lightweight. They say that our bottle is heavy, so it is stronger. But it is not the real case. Right? You will see like this bottle, we make it in about 370, 380 grams. The competition makes it in about 500 grams. Right? And still our bottle is more stronger. So weight is important, but not always the most important criteria for the strength of the bottle. Right. Next is 100% recyclability, we have already discussed. Okay, so glass recyclability, I think we can skip on this. Glass is inert, we all know it's made of natural minerals like sand, environmentally harmless. Glass is immortal and remains unchanged over time. So whenever excavations happens, we still find glass because it does not change over time, right? Now I'll give you a brief idea that whenever you are buying glass bottles, how do you make the right choices? Everyone knows what is inert. What is inert? Inert is it does not react. Impermeable is you cannot put anything inside. You cannot puncture anything inside, right? Odorless, non-leaching. It does not leach in the product. Like sometimes when you have in plastic bottles, there is a certain smells that comes in. It is plastic leaching into bottles. Microplastics is a very big problem these days. Infinitely recyclable, microwave safe. It's certainly fragile and FDA approved. Hermetic sealing is basically a vacuum sealing. Prolonged shelf life and connoting premium quality to the customers. So extended shelf life. So do one exercise. So whenever you go back home, go back to any malls, look at ketchup from same brand of companies. So if you look at the same brand of companies in glass, the shelf life is usually 1 year and above. When the same company packs it in pouches or in plastic bottles, the shelf life is 8 or 9 months. You see, so glass automatically gives you a longer shelf life. Now we come to some certifications and how do you select the right vendor. So food safety certificate, a lot of factories use lead to make it better glass. When you have crystals at home, so crystals quality is seen by the percentage lead they have, but crystal is not meant to be consumed. You don't pack food in crystals, right? So one, it has to be lead free. You should get a COA, certificate of analysis, USP classifications, whether United States Pharmacopoeia type 1, 2, 3. There are 3 types of glass, different type of glasses are used. AQL, always fix up with your vendor what is the assured quality level, what are the defects that can come and how much defects will come. Then it's plant audit, multi-geography supply capability. One thing that I want you to notice is, can you notice some digits on the bottom of the bottle?
Yes, sir.
Can anybody define what is this? So you see the digits in the center?
Here.
Yeah. You see that? No, it's not here. I'll tell you. You see the digits in the center?
Yes.
So those digit is the mold number. Because almost 24, 25 molds are run together. So whenever a defect comes, and I think most of you will have different digit. Now, what is the digit in your bottle? What is it written? 10. What is in yours? 28. What is in yours? The number? 33. You see, most of the bottle you will have different numbers because these are different molds. The number of the molds. So 24 molds run together when the bottles are being manufactured, and in case any quality problem comes, immediately that mold can be stopped and then mold can be replaced with a new mold, right? Next you see H. That is the manufacturer symbol, right? That who is the manufacturer of the bottle? Hindustan, right? National Glass, H&G, yeah. And then do you see B? B is the plant location. So like H&G has 7 plants across India. B is Bahadurgarh, which is where this bottle is made, right? So a lot of times manufacturers or suppliers don't put all these symbols on the bottle to escape any traceability, right? And traceability is a very important factor in packaging. In case any problem comes after you have packed the product in the market, how do you identify where the packaging was, right? So always make it a point, whenever you are buying any kind of packaging material, it should have manufacturer symbol. Whenever you buy laminates, whenever you buy boxes, there is a packaging symbol on that, right? So in glass, a lot of people skip that. So always make it a point that when you buy glass, there should be a manufacturer symbol on the bottle, right? And then there's a drawing of glass bottles and jars. So this is a usual drawing that I showed you before. This is very important for quality control. Do you see tolerances over here? Plus minus 1.5. Plus minus 1.5. What can be the impact of this tolerance? Can anybody share that? Why is it important to see what the tolerance is? Do you understand what tolerance is? So if it is written 69 plus minus 1.5, so it means the diameter of the bottle can be 67.5 to 70.5, right? Now I want you to calculate what would be the length of the label. You know the formula of circumference? 2 pi r. 2 pi r, can you calculate? So pi is 3.14. Just calculate fast. So we have two diameters. One is 67.5. One is 70.5. Multiplied by 3.4 because we already have 2r. 3.14 से आप multiply कर दो. In the same bottle, you have a circumference which is 1 centimeter plus or minus. If I give you this bottle, it can be 211, and if I give you this bottle, it can be 221. So this is not errors because it is a blown process. So this is part of the manufacturing process. So these are not errors, but these are predefined quality parameters. But I want you to understand why getting a drawing is important. Because if you get this sample, what would be the circumference of this bottle? For example, X, right? But when you get the actual supplies, it will be X plus minus, right? Imagine you get a sample from a customer, from a supplier, and you plan your label as per this bottle. Label you will plan like a circumference, right? And you plan an overlapping label. Now when you get supplies, that circumference changes. What happens to your label? But you've already got it printed. You call the supplier, you send me some other sample, you are sending me some other supplies. Right? Right? So what is important is always ask for the drawing. Very few suppliers give you, but always this same problem will have in the machine also. You send this sample to your machine supplier, he will make as per this dia, he is also right. Supposingly this was 67.5 bottle and the bottle that was supplied to you was 70.5, totally out of tolerance. Because machine supplier will also take a plus minus 1.5 tolerance. So always whenever you start packaging, especially in glass, always get the drawing, get all tolerances and make your designs as per the tolerances given in the drawing, right? Not measuring the bottle. So this is one of the very important factors that you need to ascertain. And this, it is not that it will only impact the label. Look at the capacity, 230 plus minus 5 ml. the product, how much you are wanting to pack in the bottle, will also change based on the drawing. So this is a very important thing, that always have the drawing in hand while selecting any glass bottle. Right. So we were just talking about capacity, and now we come to another important point regarding the capacity itself. So I want you to tell me in a 400 ml bottle, pickle and jam, will it be packed same, or what will be the difference? Suppose in a 400 ml bottle we pack pickles. How much gram of pickles will come in that? 400. And if we pack jam? Yes. So this is another thing that really needs to be discussed. Jam has a lot of sugar in it. So imagine 1 kg of cotton and 1 kg of iron. How much will 1 kg of cotton be? Like this much. And 1 kg of iron will be this much. So similarly, the density of the product defines how much the bottle can hold. So usually in a 400 ml bottle, pickles is 400 grams and jam is 500 grams. This is also part of the quiz. You can pay attention to this. So whenever you pack jam, it is always 1.25 of the OFC. OFC is overflow capacity. When you fill the bottle to the brink and one more drop you pack and it falls out, that is the overflow capacity. Right? So if it is 400 ml OFC, you multiply it by 1.25 to get how much jam will get packed in it. Otherwise, supplier may say that it's a 400 ml bottle and you wanted 400 gram of jam, but when you get the supplies, you will see you are getting 500 grams in the jar. You will say I have ordered 400 ml. Supplier will say I have supplied 400 ml. So always check what is the specific density or gravity of your product. Are you getting the importance of checking this? So never assume, always check in lab what is the density of your product and then see how much of it will come in the glass. So for honey also, honey is a heavy product. It is same as jam. Pickle will be same as OFC. Then ketchup will be 1.12. Tea, coffee. So like coffee is very, very light. So in a 500 gram jar, only about 150 or 160 grams of coffee can come. Because it is porous and it's very light. When you talk on dry fruit, supposingly you pack ground dry fruit versus whole dry fruit, the quantity in the glass will change. Is this clear? So how it also helps is, supposingly you are a food packaging company and you have to make pickle and jam both. So take just one bottle and pack 400 gram of pickle and 500 gram of jam instead of taking different bottles. When you take one common bottle, you are reducing the number of bottles you buy, thereby having less money to spend on the bottles. These are different. So I'll give you some industry-wise usages. This is the advantage that we have discussed. And if you see the flavoring, so this is weeks, till 22 weeks it is seen. And the natural flavoring content of orange juice, it remains maximum in glass. Then there are different type of cartons wherein you see it is much lower as the time passes by. So that is why you see the shelf life in glass is always much higher than you see shelf life in any other products. This is an actual study done, that what is the percentage of flavoring remaining after 22 weeks. And then it keeps on degrading in many materials. I'll move on. So some of the usages, like you say hospitality. I see a few people from hospitality. So this is used by Taj Hotel, this is by Ibis. I'm giving you some industry usages so that you can have an idea where glass is being adopted right now. It is used for water. A lot of countries are now going totally plastic free. So these are reusable bottles that you drink water and the hotel packs the water again and it keeps on reusing in the hotel itself. Then it is pharmaceutical. 3 types of glass are used in pharmaceutical: borosilicate, soda lime and soda lime silicate. These are for cosmetics, cream jars, serums. These are some applications that are used in cosmetics. These are some decorations on glass. You can do some value addition, printing, coating, like you see a lot of perfume bottles. These are the value additions applicable to glass bottles. Right? Now let's come at some of the common problems that you might face when you're using bottles during your process. So one is general breakages in filling line and packaging. So what happens, what we have seen is usually when the glass is transported, there is hardly any breakages, but sometimes a star mark happens there because of collision of the bottles. And customer packs those bottles without pre-inspecting the bottles, right? And when that bottle is packed, at that time it breaks. So it's always advisable to pre-inspect the bottles before using, right? Then is breakages during autoclave. So when you pack milk, when you pack soya milk or any kind of dairy product, and if you're doing autoclave, so autoclave is a process which is used. Autoclave is a process wherein you pack the products in the bottle and then you subject it to a very high temperature for 20 minutes. You take the temperature to 121 degrees, hold it there for some time and then bring it down. What happens during this process is there is expansion inside the bottle, right? And if you have not left sufficient space in the bottle to give that product or air to expand, the bottle will burst. Exactly, right? So this is the important part, that you always need to keep 8 to 10% of the product empty. Supposing this is a 1000 ml bottle, so you will have to fill it till here, 100 ml to be kept empty. So when you autoclave it, there is sufficient space for product and air to expand. And then it cools down, it comes down to this level and it's okay. That is why you will see glass bottles, you will never find in any market that it is filled till the top. Have you ever seen there is a label here in ketchups? Have you seen those labels? So the purpose of those labels are actually to hide the empty spaces. Because the ketchup is filled till here and if you see it empty, you will not buy it. So they put a label on top of it. So this is one thing which is very, very important to know whenever you are heating the products. Then is sometimes like a product like jam, it does not require autoclave, but the product itself is filled hot. So the jam is filled at about temperature of 90 degrees. So 90 degrees Celsius is quite high, and the problem that customers face is as soon as they put jam in the bottle breaks, right? So the solution for this is you need to just preheat the bottle a little bit, use a steam, use hot water, bring the temperature to so that the difference is less than 42 degrees. 42 degrees is a very important temperature in glass packaging. It's known as a thermal shock temperature. Whenever you subject bottle to a temperature difference of 42 degrees or more, the breakages will increase. Not all bottles will break, but you will find higher chances of breakage of the bottle. So if you have to pack a product at 90 degrees, you bring it to about 48 degrees or 50-55 degrees the bottle temperature and then pack jam in it. So the bottle will not break. Have you ever seen that sometimes when we pour tea, we put a spoon before pouring a tea? Anybody has done that? So historically when glass were not that great quality, before putting hot tea in the glass, we used to put a spoon so that the temperature is absorbed by the spoon also. Right? So these are common lug cap sealing. So we showed you the anti-clockwise and then clockwise sealing. And last is tamper proofing. So you put a small seal on top of it to make it tamper proof. Got it. This is again headspace during sterilization that we discussed. Leakage in glass bottle. Did you see during the manufacturing process there was a nozzle which was checking the internal dia, right? So a lot of times you have to put plug in the bottle to seal the bottle and then you put cap on it. So if the internal dia is not controlled, you will not able to put the plug. So whenever you plan a product in such a way that you have to use a plug, you need to tell the supplier beforehand that the inner dia needs to be controlled, right? Next is vacuum formation that happens in jam because of the temperature, and this we already covered. Okay, so yeah, as promised, 40 minutes, we are done. We'll go with the quiz. Isha, can you launch the quiz? You can just, I'll just invite Isha to launch the quiz and just answer whatever you can have. Should I start from here? Want to come? Times it can be recycled, and this bottle is exactly used for milk only, and what we have studied that it usually recycles up to 72 or 75 times. So you buy the bottles today and you can pack up to 72 liters of milk and you can sell it.
No, I'm saying not recycle.
Reuse.
Reuse.
Yes, you can give it to the customer Customer takes out the milk, give you the bottle back, then you give it back again in the same bottle, then it comes back 72 times.
For filling, second time filling.
No.
For second
So,
time
so what we've seen is on an average, when there's a 1500 liter farm, we did a survey how many bottles they bought in a year and how many liters of milk they sold. And we divided the milk sold by the bottles bought and came out to be 72.
I'm saying process of sterilization.
Process of sterilization, yes.
Prior to
When you come back,
yeah,
yes. So you usually wash it by a very hot bottle, very hot as in about 60 degrees and then 90 degrees. It sterilizes the bottles.
Boil it, sir.
No, you use hot water spray,
Hot water spray.
hot water jet. Yes.
Rotator and
First you with the normal water, then with 60 degrees and then 90 degrees. Sterilizes. So a very good point about glass is it's not easy to make scratches on this. You know what happens with plastic and other materials, even metals, there is a scratch or dent which develops and bacteria forms in that, right? Whereas in glass, the surface removes absolutely smooth. So there is no problem of sterilization in glass. You can sterilize it just with hot water. Very hot water, flush it and good to go.
this bottle cost just enough
20 to 25 INR.
for this 1 liter, right?
I think about 20 or 25 rupees, something like that. So per liter cost is actually very less. So we do 20, 25 divided by 72, that's 30, 40 paisa. There is a video on YouTube on milk only, specifically for milk. I think it's a 20, 25 minutes video where the entire economics of milk reusing the bottles is explained. Because we are short on time, otherwise I usually explain this here also. Yeah, yes. More questions? Yeah.
Why this shape is common?
See, round is the most easy shape to make and pack.
Same as a
It's easy to hold. It's very easy to hold. It's a very generic, very simple. So you can make it as complicated as possible, but it's very easy to hold.
I see lots of manufacturers having the same.
Yes. We made it for the first time in India and a lot of people copied.
Do you have like IP issues regarding this?
No. No. That is a problem globally, that you can have an IP issue with the brand, and if you register that bottle and if you have your name embossed, then nobody else gets that bottle. But if it's a general market bottle, everybody can make that bottle.
In our country, it's quite cold, and during winter, when you pour hot water, glass gets cracked. Some doesn't. Why is it?
So when we discussed about the thermal shock, 42 degrees. If it is cold and usually it's about 0 to 5 degrees and you put a hot liquid in it, the chances of glass cracking is high. So what you can do is if you are packaging, if there's a proper production line, then you need to heat the bottle first to a certain temperature so that the temperature of filling product and the bottle reduces, then it will not break. If you are just using at home, put like 1 or 2 spoons in the glass before pouring the hot liquid, or you can wash the glass with little hot before pouring the liquid. If you are putting tea in a cold glass, put 2-3 spoons in that. It will not break. It just the temperature difference is there. Yeah. Any more questions? Okay, TT and JD have logged in. Can you go to Kahoot? So let's see who the winner is. It's podium. Third is JD. Let's clap for JD. Second is Dupso Gang and
JD and please stand up.
Please stand up, JD and
so you can sit down. You can sit down. So let's give the prize to the Dupso Gang. Can please be here. Who is? Can I see? So this is a Swiss chocolate lint, and so let's just a round of applause for. All right. Thank you so much. Have a good time. Oops. Okay. It's 5:31. Are we on time?
Yes, sir.
Perfect. Any more questions? You can have my number. You can have my website. And that's all that I had to share. If you still have questions, easy to ask.